3.3C is in Charlie. College Algebra. We're on page 207 dealing with variation. All right, in section 2.1 we talked about direct variation. And if you remember, we had this. And I said, remember to, first of all, when you're looking at story problems, look at what it's asking, whether it's talking about direct variation or inverse variation, okay? Because direct variation looks like that. Inverse variation looks like that. It's divided, okay? So that's the first thing you want to do. Does it say direct or does it say inverse? Now, when you're looking at direct variation as the nth power, oftentimes the story problems will be written so that the direct variation looks like this. And this x here has an exponent. And it will tell you, okay? It's not going to assume that you know. I mean, there's really no way to just know this. In fact, if you look at example 9, it says the illumination produced by a light varies inversely, which we'll ignore that part right now, as the square of the distance, okay? So by saying that, I know that I'm going to have an exponent because I'm going to have a square of the distance, and in this case, the distance will be x. So that's telling me that direct variation, which is the k of x, or k times x, but I'm also going to have an exponent because it says the square, okay? It may say the cube sometime, and that means this number up here will be a 3. Okay, so the first thing we're going to look at is it saying direct variation? Is it saying inverse? Okay, in this particular problem, it says the inverse varies inversely, which means we're going to use this problem as the square. So it said square, so I'm going to put the 2 there in order to have a correct equation here for that. Okay, so if it says direct variation or inverse variation, you're going to use either this one or this one. And then if it says anything about a square or a cube or a fourth power or something like that, the x is going to get that variable. Okay? So let's see if I'm missing anything prior to example 9. I don't think I am there, but let's look at example 8. Don't want to miss out on something that's kind of elementary, that kind of gets your feet wet on this direct variation here. In the production of an item, the number of units of one raw material required varies as the cube of the number. So you've got cubes, so you know that you're going to deal with a 3 as an exponent. So it varies as the cube. All right, so it doesn't say inversely, doesn't say directly, but if it does say vary and doesn't use the word inversely, you can assume that it's going to be this particular formula. And it says it varies as the cube, so that means that x is going to get a 3 up there. So suppose 500 of the first and 5 of the second are required to produce 100 units. How many units of the first raw material are required if the number of units produced requires 10 units of the second raw material? Oh my gosh, that's like so confusing, isn't it? Okay, so reread it a couple times and make sure you know what they want you to do. So if x is the number of units of the second raw material, and y is the number of units of the first. So I'm going to put, just to make it easier for myself, first and second. So I know which one is x, which one is y. Then y varies as the cube of x. So that's going to look like that. All right. So because y is 500, and when x is 5, and what we're doing, remember with the direct variation back in, what was it, 2.1, we multiplied, and we found k first, and then we found what they wanted us to do. So we go ahead and do this. 500, 5 cubed is 125, 5 times 5 times 5. We divide by 125, and that gives me a k value then of 4. So that gives me something to work with here. So now I have, for this problem, this formula, okay? So that's what I'm doing, is I'm taking the general form of the equation, putting in the information they have to find k to come up with an equation that works only for this particular situation, because not every situation will this number be for. It's just in this one. Okay, so now there's my specific form of the equation for this problem. So, that being the case, when we have x being, or our second piece of raw material being 10, now I can find y. I can find how much of the first raw material are required, which is what the question is. So I've got 4 times 10 times 10 is 100 times 10 is 1,000. So that means I need 4,000 of the first raw material if I'm going to mix it with 10 of the second raw material. Okay, so that's what we're doing there as far as the variation using nth powers. All right, so that brings us back again to inverse variation. Let's go to example 9. And I was trying to get ahead of myself a little bit, but the illumination produced by light varies inversely. So I know I'm using that equation as the square of the distance from the source of light. If the illumination 30 feet from the light source is 60 candela, I have no clue what a candela is, but I'm assuming it's like the amount of light that it sheds on the ground or something. What is the illumination 20 feet from the source? Okay, so it's probably going to be more because you're closer to the source, so the light's probably going to be brighter, or whatever candela means. All right, so that being the information, one of the things that they do is they give you 30 feet and they give you 60 candela. They give you those two in order for you to find k. And once you find k, then you're going to use the rest of the problem. So let's go ahead, and they use some different letters here. Instead of y, they used L for illumination, and they're using D as distance. So they gave us 30 feet and 60 candelas. So we've got 60 equals k over 30 squared. So k then, when we do this, equals 54,000. That doesn't really mean anything to me. It just allows me to take this general equation and make it specific to what I'm doing here. Now I can go to my original equation right here where I switch the letters around a little bit. And what else do they give me? What is the illumination 20 feet from the source? So I'm looking for L. They didn't give me that, but I know my K is 54,000. And my distance, they said, is 20 feet, and I'm going to square that. A lot of people will make a mistake because they won't square the 20. They'll forget that. So now I've got 54,000 over 20 squared is 400, and I get 135 for an answer there. Okay, and we were right. It is brighter the closer you get to the source. So that's pretty much it for 3.3. Not too terrible. Probably one of the biggest struggles here is, to me anyway, in this lesson, is the piecewise definition and the step function. That can be a little tricky if you're not really watching there. The absolute value function, that shouldn't throw you too much. Power functions, yeah, you should be okay with that. Root functions, reciprocal, variation, I think I went over it all pretty well. One of the things, and I'm hoping that they go into this in a little more detail, I don't remember off the top of my head if I assign number 15 in 3.3, but number 15 has what is called a greatest integer function. All right, so if I did assign that, I don't have my list of what I've assigned for the section there, I'll have to go over that. I'm assuming they're going to go over it better later, because It's kind of confusing, the greatest integer function. You know, it's almost like you have to have a graph in order to really understand what a greatest integer function is and what it looks like and how it works. But it pretty much looks like the graph that we did that they called a step function on page 199. That's basically a greatest integer function. But anyway, hopefully they'll go over it more later on that. But anyway, if I did assignment, let's just skip it for now and we can come back to it later. Anyway, that's it for 3.3.